Hi, welcome back to Unit 5 here in AP Physics C. This is topic 5.2. Here we're going to make a connection between linear and rotational motion. Okay, and so what happens is here in the first one, so for a point at a distance r from a fixed axis of motion, the linear distance is traveled is just simply going to be the arc length equation. No hiding it, right? So, but the arc length equation is how you write it in math. Here we would write this as delta x equals r delta theta. So what does that mean? As we go from here, from our starting position to our final position, we are traveling not only radially or rotationally, we're also traveling linearly. If you were to take it and roll a round object, one complete revolution, you would travel the circumference of the circle. If I only traveled so far in terms of an angular position, I only travel a piece of that circle, and that's where you get the arc length from. Okay. Now, derived relationships of linear velocity and of the tangential component of acceleration to the respective angular quantities are given by these following equations. So first one is given to you, S or x equals r theta, V equals r omega. In fact, let's change that S to x just so we can, keep it together with our physics equations or physics. I'm trying to say quantities or variables. So you have position is r times theta, again, arc length. Linear velocity, right? So the tangential velocity as it travels around the circle is r omega, so r times the angular velocity. And then the angular acceleration, it's r times linear acceleration is r times alpha. Now, one thing to note, this bullet point is very important because what happens is on free response questions, it may be, a justify your answer type thing. It also may be a multiple choice, more conceptual based multiple choice. But so for rigid systems, all points within the system have the same angular velocity and angular acceleration. So what does that mean? Theta, omega, and alpha will always be the same. X, V, and A will be different based on the location, right? Based on R. So the further you are from the axis of rotation, the farther you move, the faster you move, the quicker you're accelerated. All right, so let's look at an example problem. We have a wheel of 0.5 meter, a wheel of radius 0.5 meters rolls without slipping on a horizontal surface. The axle of the wheel advances at constant velocity, moving a distance of 20 meters in 5 seconds. The angular speed of the wheel about its point of the contact on the surface is. So first thing we do, right, how fast is it moving linearly? So we do 20 meters over 5 seconds. That's 4 meters per second. Okay, and then we just simply plug it into our V equals r omega equation, but we solve this for omega. So we do V, which is 4 meters per second, divided by R, which is 0.5 meters. And you end up with an angular velocity of 8 radians per second. Now, I did fail to mention this back in the first video. If we go back, theta is measured in radians. Omega is measured in radians per second, and alpha is measured in radians per second squared. Okay, so in the next video, so we're sliding out of the kinematics world and we're going to move into the dynamics world.